All right, here we go. Welcome to semester 1, week 6. Okay. Now you're going to notice, I'm going to teach you a whole bunch of new things. It is week 1 of the 4-week period. Okay. So week 1 kind of has a lot, and then we practice. And then by the end, you guys are masters of the concepts. So number 1, you're just sketching a graph. It is in slope intercept. I need you guys to do that on your own. Okay? Or request it at the end. Number 2, I've had actually more questions on this, so we're going to practice this one. Number 2, it is not in slope intercept form. It is in standard form. Okay, there is a shortcut called the finger method, but we're not going to do the finger method. We are going to convert it to slope intercept form. Okay, so what do I do first? Yep. How about you, Zoomers? What do I do first to convert it to slope intercept form? We're moving the x. So the opposite of positive 2x is, yeah, notice that negative is attached to the y. The x's are positive, so I'm going to subtract 2 x's. Yeah, do you see that the negative is attached to the y? Now, not like terms. I cannot combine those. So negative 2x minus 4. Okay, so that's really an invisible 1. Next step. All right, divide by negative 1. Y is equal to, notice we're changing all signs. They actually were all negative. They're all changing to positive. Awesome. Thank you. Okay, what is M and what is B? M is what? Not the X though, right? Okay, so we're going to write 2 over 1. Yeah, because it's rise over run. And B is, what is B? Thank you. B is 4. So begin at 4. So we go rise over run, up 2 over 1. Okay, so how do I get the other side? Now that's a ray, that's not a line. Okay, so -2 over -1, right? Negatives cancel, we would still get positive 2. So we could go down to back 1. And there is the other part of my line. And I still have my voice back. It's been like weeks. All right. So standard form, convert to slope intercept, and get your slope and your y-intercept. Okay, plug the values in to the piecewise function. The dividing point is 2. Now, if I'm looking at numbers to the left of 2, am I going to look at x plus 5 or x squared plus 1? Okay, so step 1 is choose which equation is appropriate, which equation it's referring to. Yeah. So if I'm looking now, it just so happens that this less than sign matches that arrow. You guys, isn't that cool? The less than sign matches the arrow. It's less than, but isn't it also kind of saying to the left, to the left, to the left? Kind of like line dance. Okay, so we're going to use x plus 5 to the left of my dividing point. Now, notice there's no equal sign here, just less than. So open circle. Notice this one. That's pointing in what direction? To the right. Yeah. So now we're going to have a closed circle to the right. And we notice in a nice bright color that this arrow matches that arrow. And we have equal to, correct. Okay, so this is going to be x squared plus 1. So this is f of 4, which means that 4, I'm going to do what with that 4? Plug it in. So we got to choose and we're going to plug in. Choose, plug in. Okay, awesome. 4 is right here. Yeah. Can everyone see that we plug into x squared plus 1? Okay, so 4 squared plus 1, okay, Zoomers, is 16 plus 1 is 17. Thank you. Okay, f of negative 1. By the way, here's the 0. F of negative 1. X plus 5 or x squared plus 1? All right. Whoops. Wait. What am I doing? This is wrong. 0's here. You're like, what is she doing? Okay, negative 1 is right here. So it's going into x plus 5. Yeah. So we have negative 1 plus 5 is 4. All right, awesome. That doesn't go there. It goes right here. Okay, how about 2? Uh-oh. I see a 2 on both of them. Now we have to decide which equation, top or bottom, x plus 5 or x squared plus 1. All right, you guys are great. So it goes into bottom because that's the one that has a filled in dot. So 2 squared plus 1 is, all right, 5. Okay, so that is choose and plug in. All you have to do is choose and plug in. You don't even have to technically do that, but it helps us to see what's going on. Okay, now let's graph. Now, the method I used last week was, let's have a name for it, graph and erase. Okay, now we did a video this week. I believe it was the Edpuzzle video where he did 2-point tables. So that's what we're going to practice right now. 2-point tables. Okay. So I have, now this confuses me. So I just like to put y equals. I feel more comfortable with y equals. So I'm going to change it from function notation into linear notation. So I have to, okay, I'm not going to make a number line. So I can if we want to. y equals negative x minus 3 and y equals 3. Yeah? Okay, 2-point tables. Now this is funny. There's this certain number that keeps getting repeated. And it does for the other one too. My silly problem generator. Okay, now this problem, this number right here comes from the boundary. Yeah, x equals 3 goes on the first line. And I got it from the boundary, not from that one, not from that one. That's kind of not great that they both have a 3. Everything's a 3 here. Yeah, I got it from the boundary. Okay, so plug 3 in. And what do you get? Carefully. Did I gain or lose weight here? And then did I gain or lose weight here? Subtract. I subtracted 3, right? I have a negative 3. Okay, so we're going to go keep, change, change. So that's negative 6, right? Okay, I need to erase this. I don't have that much room. Okay, now look at this. This is where we are right here. Okay, notice that this kind of says, it says less than, it also says left. Okay, my next x value needs to be an x value to the left of 3, right? So picture a number line to the left of 3. So what are we going to pick? Or 1, or my favorite number to plug in is 0. Is 0 to the left of 3 on a number line? Yes. You with me? And we can see it here. Let's draw. Oh, you know what? We did this last week. I'm going to highlight the boundary line. Okay, I like plugging in 0. So now we have negative 0 minus 3 is negative 3. Okay, now I know that this is linear, right? There's no exponents, it's linear. So I'm going to connect 3, negative 6 and 0, negative 3. But I haven't quite decided. Okay, I know. Hang in there. Yeah, do you see how I did that? But we don't know that those are necessarily going to be open circles. Let's talk about the ends of that line. Open circle or closed circle? Yeah, do we see that it's closed? Yeah. And then what is this end going to look like? Does it stop, or actually is it going to keep going to the left forever? Is this to the left of 3 forever? Yeah. Forever. Yeah, do we see that this looks like that forever. Closed circle to the left. Oh, look, this also looks like left. To the left of 3, to the left of x equals 3 forever. Okay, let's change colors. Okay, now we have the line y equals 3. And I'm like, oh my gosh, I don't remember. Is this a horizontal or a vertical line? And then I think of the word yeah, which reminds me that y equals is horizontal. Ah, that's a horizontal line. Okay, so here's my boundary number. When x is 3, what is y? Uh-huh. 3.
Oh, because there's no X.
There's no x. You're not actually plugging in. Okay, so now, do I need a point to the left of x equals 3 or to the right? Right, yeah. Okay, so a point to the right, let's do 4. Okay, this is cluttered. Okay, notice no variable. This is constant. It is always 3. No matter what I plug in for x, y is always 3. So when x is 3, y is 3. When x is 4, y is what? Y is constant. Y is always 3. Yeah, y is always 3. There's no variable. Y is constant. So let's plug this in. When x is 3, y is 3. When x is 4, I don't like that one. Let's do 6. When x is 6, what is y? 3. Always 3. Okay, now we need to decide what the endpoints look like. How about this one? Open circle, closed circle, or arrow? Ding, ding, ding. Nice. Yeah, Zoomers. Open circle, closed circle, or arrow? Open circle, right? No equal to. Now, this says to the right of x equals 3. So this one is an arrow. Okay, get rid of this piecewise function. So what would be a story? This is like, oh no, I'm losing money. I'm losing money. I'm losing money. And then on day 3, okay, I did something. I stopped losing money. I went from losing to maintaining. Okay. Or this is like, I'm on a diet. I'm losing weight. I'm losing weight. And then I stopped my diet and then I just maintained. Okay. So this tells a story of one thing was happening and then another thing was happening. So that's a piecewise function. Yeah. We don't totally hate it, right? Let's do another one. Very similar, just like the first one. Piecewise function. So we have two equations. Y equals 2x plus 2 and y equals 2. Okay, okay. I think this one's going to be better. Okay. Everyone okay with step one? What's my next step? Okay, good. The next step is make a table, point table. And I think that Edpuzzles this week. Okay. What is the X value for the first line of my point table? Ding, ding, ding. Yeah. It comes from right here. Yeah, the boundary. All right. So I'm going to highlight the boundary and I'm going to put X equals 1 on the top row of my table. Okay, plug in. 2 times 1 plus 2 is? All right, 4. Let's plug it in here. This is a constant function. No X value, right? It's constant. So when X is 1, Y is 2. And we also think of, yeah, a Y equals is horizontal. Okay, I need my next X value. So do I want this X value to be to the left of 1 or to the right of 1? Okay, we have a vote. We have another vote and they agree. Yeah, can we see that this one is left? That's an E. Yeah. And this one is right. Okay. So to the left of 1. So to the left of 1, I'm going to pick 0. Although it's going to be really small. Anyway, now how about this one? Do I want an X value to the left of 1 or right of 1? Okay, now I need an X value to the right of 1. I'm going to go ahead and say 4. Gives me a little bit of space. I hate to always be so crowded on the boundary. Okay, is everyone okay with what I just did? I picked my boundary X and the top equation, I needed an X to the left. My bottom equation, I needed an X to the right. Are we good? It could be 3. You know what? Okay, but look, if it's 3, it's just going to be like this itty bitty little line. You can pick any number you want. Yeah, good question. Now, you know I love picking 0. Any number to the right is fine for the second one. Any number to the left is fine for the first one, but I love plugging in 0. Yeah, good. Look at that. You just clarified for multiple people, not just yourself. Okay. Which is why in some ways you guys are more interactive on Zoom, because otherwise you don't like to raise your hand and ask me questions. I mean, some of you do. Yeah. Okay. So I picked a number to the left and I love 0. I picked a number to the right and I just wanted to leave a little more space. So I picked 4. You could pick 2. Okay. So let's talk about this one. When X is 0, 2 times 0 plus 2, what is Y? Yeah, 2? Okay, so let's plug those in pink. So this is going to be to the left. It is red. Anyway, this is going to be to the left. So 1, 4. I don't know what this open circle or closed circle yet. And 0, 2. Are we okay so far? Now we need to decide the ends of my line. This one right here at X equals 1 is an okay, so what is this telling me? Start at 1, not equal to. Notice this is open. And go to the left. Yeah. Arrow. Do you see why the arrow is there? Notice I'm going from the boundary to the left. Yeah. From the boundary to the left. Yeah. Open circle to the left. Are we good? Okay. Now, I didn't know what it was going to look like. And then I realized this one right here was not a circle. It was an arrow. Yeah, I probably shouldn't have put anything. Do we see how it's going to the left through the circle? So that circle actually disappeared because it turned out to be an arrow. Ah, yeah, better. Okay, let's do purple. Okay, let's talk about this one. So that's this right here. Let's plug in 4. This is a constant function. When X is 1, Y is 2. When X is 4, Y is 2, right? Notice the X is missing. So we have 1, 2, and 2, 2, sorry, 4, 2. So you guys might not like it that I put those open circles when I don't know actually what's going to happen. Okay, now I'm going to make all this disappear for a second. Okay, sorry, this looks horrible. What is this telling us right here? This is telling us start at the boundary. Yeah, it's telling us three things. It's saying start at the boundary, ding, ding, ding. Closed circle. And go to the right. Can you see that that's what it's telling us? Start at the boundary, closed circle to the right. Does anyone have any questions about 1, 2, or 3? Okay, don't see any questions. Okay. No. Okay. So start at the boundary, closed circle, go to the right. So that's what we're going to do. We're going to start at the boundary, closed circle. That circle is going to disappear. Horizontal line to the right, erase the boundary. There's my line. Now you can leave the boundary. For me, you can leave the boundary. Like next year, math analysis, maybe you should get rid of the boundary. Okay. So for me, I don't care. There we go. Better? Okay. So we have piecewise function, category name, piecewise function. Notice it is actually only one function. Okay, good. It wasn't easier. You just get it more. Okay, you're starting to get it. So that was piecewise function. This is simultaneous equations. Now, just think, if you were in traditional school, these would not be on the same day. I would lecture on 5 different days, but lucky you, you get this all squished into one day. Okay, so, but you guys are amazing and you can handle this. Okay, solve by graphing. So we have 1 point here. B is 3. And M is 1/3. So let's make a graph. Or -1 over -3. Notice I have 2 equations. So let's do this one. B is -2 and M is 2 over 1. Okay. Now, what does this look like in a word problem? You see this graph? I started at 3 and went up slowly, right? This one, I started way back behind at -2, but I went up quickly. So see how it's important to see one of these lines starts higher, but goes up slowly. And one of these lines starts lower and goes up quickly. Does that make sense? All right. So now we want the solution. We want to solve. Okay. The solution is where they meet. So they are at the same place at the same time. So the solution is 3, 4. Oh, okay. This is called simultaneous equations. It's also called a system of equations. That's actually probably the more common name. Okay. So here's another one. Now, what if we don't want to graph? You know, I don't really like graphing all the time. So this is solve for substitution case A, where both are in y equals form. So substitution case A, we have both in y equals form. Okay, so when they're both in y equals form, step 1, hook them together. Hook them together. I think, what is it? Texas A&M is like, hook them. They have this little thing with their hands. Hook them together. Okay, now, can we see that we can hook this one? Can you see that I can replace the y with the x minus 1? Because look, they're both y. I can replace that y with what is equivalent to y. It's a lot of lines. Okay, step 1, we have, what type is it? Y equals y equals. If it's y equals, hook them together. Okay, so I'm taking out that y and replacing with x plus 1. Step 1, hook them together. So what do you think I'm going to do next? Solve for x. Okay, so I'm solving for x. I'm going to move all my x's over here by doing the opposite. Okay, they were in slope-intercept form. So I had 2 equations in slope-intercept form. I want to solve, so I hook them together. Okay, I'm not going to graph. I'm going to use the substitution method instead of graphing. But if I wanted to graph, I could, and I would also get the solution. Okay, to move these x's, I do the opposite. I add 4x to both sides. So 5x plus 1 is equal to 1. Yeah. Okay. Isolate your variable, subtract 1. 5x is now equal to 0. Thank you. And last step. Divide by 5. X is equal to, now, can you have a 0 on top of a fraction? Yes. Can you have a 0 under a fraction? No. Yeah. So x equals 0. What do you think I need to do next? Am I done, or is there one more thing I need to do? Okay, I need to find the value of y. Yeah, one more thing. So if I plug it in here, I get y equals 1. Agreed? If I plug it in here, -4 times 0 is 0 plus 1, I get y equals 1. X is the value that gives me the same y value, right? So y equals 1. I am looking for the x value where the y's meet. So that is the ordered pair 0, 1. Yeah, so if I graphed it, don't do this, but I have 1 and I have a line and I have another line. 0, 1 would be the point of intersection. Now, the first time you see something, it's difficult. So we hook them together, solve for x, solve for y. Done. Okay. So we're also going to do substitution. But this time I only have one that's solved for y, one slope intercept, and one standard form. So this is substitution, but it's going to look different because I don't have y equals y equals. Okay, you ready? Now, this is the one that we're working with. This is the one that's isolated. So take your standard form, take out the y. So substitution. Think about a substitute teacher. Your teacher is not there. This other person goes into their place. Substitute teacher. So I've removed the y. I need to put something in its place that is equivalent. So what am I going to put? And notice I put parentheses. Yeah. Okay. So in its place, I put what it's equal to 2x plus 5. Now, why did I put it into parentheses? Because I'm going to have to distribute. Yeah, if there's two terms, there's going to be some distributing. Okay, so we substitute and we solve. So I'm going to distribute. See how that's plus 2x? Now I'm distributing the outside negative. Is that going to be plus 5 or minus 5? When this goes in, this becomes minus 5. You with me? Okay. Oh, which part? Do you have a question? Okay, so let's take a look at this. Oh, go away. Okay, let's take a look at this. If I want to distribute, what does that become? Oh, okay. Let's look at this. Now I've lost it. Wait, that was negative. Okay. Okay. So let's look at the difference. Super important. Yeah. Do you see the difference? For the top one, what is getting distributed? Now, okay, Taylor Swift, I've got a blank, I got a blank space, baby. I'll multiply. Yeah, to see that blank space? So that blank space means you're multiplying the 2x. But this one is just, I'm going to put a 1 here. Okay. And now I'm going to go keep. Let's do it in a different color. Keep, change. I'm only distributing the -1. Okay. So the 2x comes down. The -1 becomes positive 2x. The -1 changes the 5 minus 5. Okay. Very important, tiny little details. So there we are. Okay. So I'm subtracting -2, that ended up plus. I'm subtracting 5, there's my minus 5. Okay, hopefully better. And you know, sometimes the next one, you're going to be like, ah, now I get it. Okay, what's my next step? Okay, combine like terms, add them together. You may have meant add the 5. You could have added the 5. Now we're going to add the 5. What's -1 plus 5? Four. All right. What's my last step? All right. Divide by 4. X equals 1. So at this X value, I should get the same Y value no matter which equation I plug into. One of these equations is much easier to determine the value of Y. So we have the top and the bottom. Which equation would be easier for determining the value of Y? Top or bottom? Top. Okay, so we're going to plug it, but I could do either. So Y equals -2x plus 5. Plug X equals 1. And what does that give me for Y? -2 plus 5 is correct. 3. So at the point 1, 3, 1, 3 would work for both equations. It's the point where the two lines cross. And if I wanted to test it, 2 times 1 minus 3, so that's 2 minus 1 is 3, gives me -1. I could check it. Yeah, by plugging M in. So there's the solution. Okay. So we have graphing method. We have 2 types of substitution. Now look at this one. I have both equations in standard form. Okay, take a deep breath. I know you feel like your brain is full, but we're almost done. Don't look at the next page. Just trust me, we're almost done. Okay, now let's think about what the goal of these is. I have 2 equations and 2 unknowns. Right? 2 equations, 2 variables. If I have 2 unknowns, I have to have 2 equations. What I'm trying to do is the next step, go to 1 equation with 1 unknown. And then I can solve. So I'm trying to condense it from 2 equations down to 1 equation. One of those methods of putting them together is substitution. Yeah, see how at this point, I had 1 equation and 1 unknown. I used the substitution method. So if I wanted to use the substitution method, could I move the 5 over there, the 5x, and then I could plug it in? Because I would have 1 equation solved for Y. But what if I told you I had a really cool shortcut called the elimination method, which will involve fewer steps than using substitution for this problem? Yeah, are you with me? This is my favorite. This is my favorite one. Okay. The elimination method. This is also called the add down method. Okay, why can I add 2 equations together? If X No. Is it true that 5 equals 5? Yes. Is it true that 2 equals 2? Yes. If I add those equations together, I get still a true statement. 7 equals 7. As long as I'm adding trues with trues, it'll come out true. So this is the add down method. Okay, notice I want to go from 2 variables to 1 variable. So I'm going to pick which variable looks easiest to cancel when I add down. So you're going to either pick the X or the Y. Give you a hint. Don't pick the X. So we're going to pick a variable. So I'm picking the Y. Now this one, you're like, what? Of course the Y. Now the coefficient. What is a coefficient? Is it like a little number on the right or a big number in front? What is the coefficient of this X? Does the X have a coefficient? Yes, the coefficient is 5, right? That's what a coefficient is. So the coefficient must be equal but opposite signs. So look, we have +1 and -1. We are ready to add down. So if I add equals with equals, I can now add down. 5x plus -2x is 3x. What is 1y plus -y? Right back. Ding, ding, ding. Okay. 1y plus -y. Are you ready for my high tech? Bam. Pow. Look what I just did. 1y plus -y. Pow. Bam. Is 0 y's. Cancel. I now have one equation and one variable. Okay, Zoomers, how much is -15 plus 9? -6. So step 3 was add down. Step 4 is solve. Divide by 3. X is equal to -2. And then step 5 is plug in. So I need to pick an equation to plug into. I don't like the bottom one because it has a lot of negatives. I'm going to plug it into the top. Now, neither one of them is solved for y, so it kind of doesn't matter. 5 times -2 plus y equals -15. Five times -2 is -10. add 10, y equals -5. So you could either list them like that or an ordered pair, because that is the point where the two lines cross. That ordered pair works for both lines. Okay. Now, it's not quite so obvious which variable I should pick. So we have two equations in standard form, standard and standard. Pick a variable to cancel. One of those variables, we're going to multiply to make it match. We may multiply by 1 or we may multiply by both. So I want the coefficients to be same, but opposite sign. Okay, so step 1, pick a variable. Which variable would involve less work to make it have the same but opposite coefficient? Do we want to do the X or the Y? X. Okay, so we picked the X. Good choice. Now, I need the X to have the same but opposite coefficient. So I am going to multiply everything on the top equation by a certain number, because our goal is to make the X's disappear. What am I going to multiply everything in the top equation by to make the coefficients of the X's same but opposite? Basically, I'm getting the least common multiple. So I'm going to multiply everything in the top equation by anyone have a guess? To make it match and cancel the 9x. Anyone want to throw out a number? I'm going to make them both. So I want to have a negative 9x and a positive 9x, right? That's going to make them cancel. So I have a positive 9x. I'm going to multiply the top equation by -3. That's going to give me the -9. Okay. And once I get the -9, how? Yeah. Okay. So let's distribute. -9x. -3 times -4 is plus 12y. -3 times 9 is -27. And then I bring down the bottom equation, 9x minus 6y equals -9. Okay, what am I doing next? How? Add them. Add down. Too bad that little pow sign will not make it onto the video. Okay, add down. -9x and positive 9x. Pow, gone. Yay, I only have one equation, or one variable and one equation. 12y minus 6y is 6y. -27 and -9 is -36. Divide by 6. Y is equal to -6. So step 3, we solved for Y. Step 4, what do we need to do? Plug in and solve for X. I'm just going to plug into the top. 3x minus 4 times Y, which I just found out is -6, equals 9. Okay, so that's 3x, keep change. See how they both have negatives? Plus 24 equals 9. Subtract 24. 3x is equal to, what's 9 minus 24? All right, -15. Divide by 3. X equals -5 and Y equals -6. Okay, this is a lot. I wanted you to see an example of all of them. Okay, I don't think you need 2 examples to get the idea of elimination when you need to multiply. So this is going to be do not do. Okay, number 11 is do not do. Now, we do not have time. This would be good to practice, but this is do not do. Okay, not on your own. Do not do. Number 1, you're going to do on your own, but that's just graphing. And do not do. I didn't want to go fast. And then these on your own. Okay, you could do diamond problems, right? Using your chart of factors. So that is it. We are done. Okay, you're doing number 1 on your own and number 14 on your own. And you guys are amazing. Okay, you are welcome. Hopefully it helped. So you've been exposed to everything. With practice, these are not bad. Okay, piecewise function, system of equations. You are welcome. Okay, you're welcome. Thanks for asking questions. Okay, I'm going to stick around. Anyone has any questions? Otherwise, have a great week. I'll see you next Tuesday. Thank you. You too. Bye-bye. Okay, it was a 10:30 session. Okay, so we started at 10:30. But I will be sending out the video. Okay, so you can watch the video. Yeah, I only do it once. Sorry. Any other questions? Okay. Okay, guys, have a good week. Let me know. Practice these, and they're not going to be that bad. Okay, with practice.